Lesson 3.3 is graphing using linear equations, using the intercepts. We're graphing linear equations using the intercepts. Got it. Previously, you have graphed making a table where you got to choose your own domain, or in some cases, they limited or restricted the domain, and then you had to end up restricting the range. Here, though, like I said before, we're going to graph using the x and the y-intercept. So the first definition of the vocabulary says the x-coordinate of a point where a graph crosses the x-axis is called the x-intercept. The x-intercept. If I just draw a little sketch over here, ooh, that's lovely. Where it crosses the x-axis, that's going to be x comma 0. That is the x-intercept. And the y-coordinate of a point where a graph crosses the y-axis is called the y-intercept. So we could have it down here, and this would be the point 0, y. And as you can see, then we could go ahead and connect these x and y intercepts, and it does form a line. So first we're going to find out how we can actually come up with the x and the y-intercepts of an equation. This is an equation in standard form. I didn't really go over that with you last week, but I want you to write this down. Standard form is ax plus by equals c. A, b, and c are real numbers. Remember, that's the symbol for real numbers. X and y are your coordinates from the line. So again, this is called standard form. Okay, now to find the x-intercept, we know that where the x-intercept lies, the y is 0. So we can write the x-intercept, set y equal to 0, and solve for x. So if I take this equation, I'll go 7x minus 3 times 0 equals 21. That gives me 7x equals 21. Divide by 7, and x equals 3. So the x-intercept is 3. To find the y-intercept, you can see where we have a y-intercept, the x is 0. So set x equal to 0 and solve for y. So I'll do that over here. You might have more room on yours, but I just don't. So 7 times 0 minus 3y equals 21. That gives me negative 3y equals 21. So negative 3, when I divide, gives me y equals negative 7. And then I could go ahead and graph a point where x equals 3 on the x-axis and y equals negative 7 on the y-axis, and just like I did here, graph them. So it's another way to graph a line. Here, in some cases, they're going to go ahead and just give you a graph to look at, and they want to know the x and the y-intercept. Well, this is hopefully not too difficult. The x-intercept is right here, and that's the point negative 2, 0. Or we could just say x equals negative 2. And the y-intercept is right here. It's where it intersects the y-axis, and that is the point 0. It looks like we're going in steps of a half here, because this is just 2. So this is 0, 1. Or we could say y equals 1. Again, be careful, because I had the inclination, I wanted to go 0, 2, but then my eye caught the 2 up here, so you have to look at your scale. And finally, they're going to give you an equation, and they want you to label the points where the line crosses the axis. So we're going to go ahead and solve for the x and the y-intercept and then graph it. So to solve for the x-intercept, remember, we set y equal to 0. So we have 3x plus 2 times 0 equals 6. 3x equals 6. So x equals 2. So I'll come right over here and put a point where x equals 2. And the y-intercept, I set x to 0. So 3 times 0 plus 2y equals 6. 2y then equals 6, divide by 2, and y equals 3. So my y-intercept is y equals 3. And they've not told me that I'm restricting the domain or the range, so I'm going to put an arrow at both ends of the line. One other thing that I do want to add on here, in some cases you're going to be given, so just add this on somewhere, you're going to be given an equation in slope-intercept form. So maybe y equals 4x minus 12. And they're still going to want you to find the x and y intercept. This is not difficult. It's just in slope-intercept form, which I know technically we haven't talked about yet. So we can say this is in function form. But we still do it the same way. So the x-intercept, we'll set y to 0. So I get 0 equals 4x minus 12, and now I have to solve a two-step equation. So I will add 12 to both sides. 12 equals 4x, divide by 4, and my x-intercept is 3. And to find my y-intercept, I set x to 0. So I have y equals 4 times 0 minus 12, or simply y equals negative 12. So I did want to show you an example where it was also in function form. All right, there are 5 problems that I want you to try on your own. I want you to come in tomorrow with them completed. You may have to, because I didn't separate it out for you. Again, these are some problems that I want you to go ahead and work on. I didn't leave you much room, so you'll either have to do them at the bottom of the page or find a different paper to show all of your work, finding the x and the y intercept. And then on problem 4, it says graph this, so you need to graph it using the x and the y axis. You can just go ahead and sketch it on regular paper for the graph. Just make sure that you number the values, or actually you could use this graph, this grid, if you want. They already have a graph on here, but I'm pretty sure that this one will also fit, so you'll be okay with that as well. All right, if you'd like to start your assignment, here it is. It's page 167, numbers 4 to 26 even. And in the directions, in some of them, it says find the x and the y intercepts of the graph. If it does not specifically say graph it, so for example, problems 4 through 14, the directions say find the x and y intercept of the graph. That just means work it out, find the intercepts, you don't have to graph it. Problems 16 to 26, those are the ones where you actually have to find the x and the y intercept and then graph it. I'm not going to make you label the points where the line crosses the axis. I will see that in your work. So if you want to start this early, like I said, you're welcome to, and you definitely need a piece of graph paper.